is Suram and I welcome you all to my YouTube channel. Today we are continuing again with the same chapter, that is the refraction of light of standard 10th. Our today's topic is the simple effects of refraction of light. So what are the effects of the refraction? So some of the basic effects or some of the common effects that we are going to discuss. So very first is, you people might have seen a stick or appears to be bent on the upper surface when it is placed in the tub containing water or a glass containing water. Here you can see this is a tub of water, and inside this we are placing a stick. Here is the stick, this one is the stick placed inside the water. Okay. And if we see it from this side, if we are watching it from this way, then the lower surface, the rays of light will go like this. It is passing to our passing to our eyes. This is the normal line here. So it will bend away from the normal actually. So actually these rays seems to be coming from this point. Here you can see. This rays seems to be coming from this point. So actually this stick seems to be like this. It seems to be like this here. Let me differentiate with the color now. This stick seems to be like this. Here. Means it shows that there is a bend at this point. And lower surface of this stick seems to be little raised from the actual height or actual depth of this tub. Lower surface it seems to be raised, and it seems to be bend here at this surface. So that happens, that is because of the refraction. This is the effect of refraction of light. So refraction, as we have discussed from so many times earlier also, that refraction is the reason that speed of light decreases. In air the speed of light is more, and as it passes into water, the speed of light decreases. So that causes the bend in the upper surface. This you people might have understood from the simple activity that if you take one blank surface, like a straight sheet, and if it place one toy car on this blank surface, and put some sand on this and just below the plank, you're having a plank surface, and place one toy car on this surface at the height, and let it come down. Here in the plank it will come in straight line. You will see when it enters into the sand, when it enters into the sand, its direction will get changed. What is the toy car you're having? Its direction will change, because here the speed was more, and as it comes into the sand, its speed gets decreased. As the speed gets decreased, then it will change its direction also. So this is the same reason for the light also. As the light is in air is having the maximum speed, that is knowing it is 3 into 10 to the power 8 meter per second. It's 3 into 10 to the power 8 meter per second. As it entering into water, it is going to decrease into 2.25 into 10 to the power 8 meter per second. So as the speed is decreasing, right, so that will change the direction. As we have discussed the simple activity here, the simple example of toy car, it is changing the direction, right? So that is the reason of refraction of light actually. Then second case that we have discussed otherwise already, the bottom of the beaker filled with water appears to be raised. A simple thing, that beaker we are having, and inside this beaker there is the water, and in this water we are placing one coin here, is it? And if we see this coin from here, is it, from the top, the rays of light will go like this, is it, towards our eyes, and these rays are actually seems to be coming from this point, is it, where these two rays are meeting. Here the image of this coin will form, so it will seems to be little raised from the lower surface, is it? So that is again happening because of the refraction of light, is it? Apparent position and twinkling of stars. Number 3, twinkling of stars. What is the reason behind the twinkling of stars that we are going to discuss now? Twinkling of stars, right? So as you are knowing, maybe the basic thing that the stars are very far away from us, is it? And in the atmospheric air, there are the different layers actually, is it? There are the different layers in the atmosphere, is it? Different layers of air are present in the air, is it? And we are living on the surface was here, is it? And when we are watching, the stars are supposed here in the sky, is it? And stars are actually very far away from us, is it? Stars are very far away from us, right? So as we are living on this earth surface, right? We live on the earth surface, and when we watch it during the night, stars, is it? The stars are also quite big in size, but they are very much far away from us. So that's why we are able to see only very small size stars, is it? So if we are watching it during the night, you might have seen that the different layers of air. These are the layers of airs, is it? Layers of air are present onto the atmosphere. So as this ray is traveling, is it? It has to suffer. Let this ray, this is the denser ray, this lower surface air will be much denser as compared to the upper surface, you can say, is it? So this ray of light seems to be bending like this, is it? From the different layers of air it will bend, is it? Okay, so this is the position of stars, is it? Actual position of stars, but actual position of the star should be here, is it? At this point, but it seems to be at this point, is it? That is because of this ray of light is bending at the different angles because of the denser air and less denser layers of air, is it? Because of the densities of different layers, densities of different layers of air, different layers of air. The density is changing as it is changing continuously, is it? So because of that, sometimes the star is coming to its original position, sometimes it is coming to the apparent position. So that's why it seems to be twinkling, is it? Its position continuously changing, right? So that's why we are saying that it is actually twinkling. It is giving the constant light actually, but we see that it is twinkling, is it? Right? That happens because of the refraction again, is it? So now the question arises that why do the planet do not twinkle? Next is number 4. Why the planet do not twinkle? Why planet do not twinkle? Is it? Why the planets are not twinkling? Is it? What is the reason behind it? Because the planets are actually big in size as compared to stars, is it? Some of the stars are also quite big, is it? But planets are bigger in size and they are nearer to us, is it? Planets are nearer to the Earth's surface, is it? So that's why they seem to be quite bigger in size, is it? So that is the reason that they are not changing its position actually. Apparent and real position just merging with each other, you can say, is it? So that's why the planets do not twinkle, is it? So that is the reason behind it, that the stars are very far away from us and it appears to be smaller in size, and planets are quite nearer to us, is it? And that's why they do not appears to be twinkle, is it? And why does the sun appears bigger during sunset or sunrise? Fifth effect is why the sunset and sunrise, the sun appears to be bigger in size. So that is again happening because of the refraction of light, because during sunset and sunrise the sun is actually far away from us during the sunset and sunrise, and we are living on the surface. It is big away from us during the sunset and sunrise. This is the sunrise and here is the sunset. During sunset and sunrise, this distance is smaller as compared to this distance. This distance is more, right? And it means the light has to suffer the maximum refraction in this case during sunrise and sunset. Light has to suffer the more refraction. That's why the light rays seem to be bent. Okay, so apparent position of the sun and real position of the sun is little. You can say they are just merging with each other. If sun is here, its size seems to be here. That's why it becomes quite big in size. Because apparent and real position is actually merging with each other. So that's why it seems to be bigger in size. Same thing is happening during the sunset also. Right, so it seems to be bigger because of the atmospheric refraction. Right, so sometime if you are sitting in front of the fire, you might have seen the other person face that is sitting on the other side of the fire. The other person that face seems to shimmer. It seems to be vibrating. So why it is happening? That is again because of the refraction. Because the density of the air is changing because of the heat. The density of the air decreases, sometimes it is increasing. So when the hot air is going up, its density is decreasing, and cool air is coming, then its density is more. So that happens because of the density change in density, actually density of the air. So that's why it seems to be shimmering on the face. Then this is the sixth case actually, shimmering on the face. Then we have the seventh case, that is the multiple images formed in thick glass. Multiple images in a thick plane mirror. In thick plane mirror or plane mirror plate, you can say. So how it happens? If we take the example of a thick glass mirror, that this is the thick mirror, and the object is placed here and the ray of light is traveling like this. So at this surface there will be partial reflection. There will be partial reflection and partially ray of light will get refracted. So like this inside. Partial reflection and partial refraction will take place. So how it happens? Ray of light will bend. Ray of light will bend towards, and it seems to be coming like this. Will go straight. This line will go straight because it is falling at 90 degree, and this ray seems to be coming from this point. Here the image formed, first image A1, and here this ray after this, because this is the polished surface here now, downward the mirror, downward surface is the polished surface, and here the light will get reflected back again to the upper surface, and here again the refraction will take place. Partial reflection, partially diffraction. Again, here the surface, reflection, again reflection, and here is the refraction. This happens continuously, reflection and the refraction take place, and here the second image is formed, and here like this again A3, third image will formed. In this case the image formed, that is the second image. Second image here, this image will be the much brighter image. This image will be brighter image. Why this image will be much brighter? Because as the light has entered into this mirror, it is suffering the very first refraction here at this surface. The light which is refracted here, it is having the more intensity. Intensity of light is maximum here. So the light which is coming from here, now the first reflection has taken place. This is forming the second image. This image will be much brighter because the intensity of light is more. This is the image that is formed after first refraction and first reflection. Right. So as the intensity of light gets the multiple reflection, and as the intensity of the light goes on decreasing, so this becomes the diminished image. Deepen images goes on in you can say dull images. The brightness of the image goes on decreasing. The second image formed is, in this case, that is a much brighter image. So you should know how to draw this diagram actually, and which image is the brighter image. So that you must remember, that is the second image. So with this we have discussed the complete simple effects of refraction of light. We will start with the next topic next time. That is, numericals are based on this. That is an important topic, that is total and non-reflection.